Hey, good evening, everyone. I hope my voice is loud and clear. Thanks a lot. Um, just give me a couple of minutes. I am setting few things up, and then what we'll do, we'll start up the session. Um, I'm just trying to load the. I think we will have enough time for that. Anyways, let's start the session. Right. Just one second. Let me share my screen. I hope everyone is doing good. It's late night. Your office is over, I guess. Awesome. Very nice. Very nice. We will be discussing a pretty heavy duty topic, but before that, let me first introduce myself. Let me first share my screen, and then we can um, start our discussions, right? Okay. I hope you can share my screen, see my screen. Can I get a quick confirmation? Yes, thank you very much. Right, thanks a lot. So my name is Sandeepan, Sandeepan Basu. I have about 20 years of industry experience in software engineering, product development, and building intelligence systems and startups. I'm primarily a end-to-end product guy, um, and have been instrumental in many scalable B2B and as well as B2C systems. Engineer at heart, I code a lot, and I have been building systems which uses applied AI and operational data science with both big data as well as small data with ML ops for quite some time now. I have been enjoying teaching, especially for past 12 plus months. I think it's almost been 18 months, and here you are. We hope to have a nice session for next, 11 days, right? 11 days. Um, okay. Let's talk about Simplilearn. As you know, it's one of the leading edtech. It's there in existence for the last 12 years. This is a little bit older size slide. However, we can take some clue out of it. You have done the right choice in joining Simplilearn's courses. Its journey has been fairly smooth as so far, and in COVID, we know that this platform has allowed a lot of us upgrade our skills, right? Um, it has been a pretty it has won many awards over the years. This is not new. Established and headquartered in Silicon Valley, right? There are many more categories that Simplilearn offers from its scale of teaching, and our track is data science and artificial intelligence, right? Data and artificial intelligence. We will be actually teaching a very specific topic on deep learning with TensorFlow. Um, let's see that what's your journey going to be. I think that this may be a repeat for some of you. It may not be repeat for some. So just to have a balance around, we can just quickly go over it, and then we can go to our main content. So overall, we'll be using the platform that Simplilearn has provided. It has an app. You can actually learn things on the go, and revise videos, which is also a very good way of reminding yourself. I believe that most of the learning that happens is after the class. What you do after the class is what it makes break. What that is what is important. You have to spend a certain amount of time. I leave it up to you to go through it, right? These are fairly deep topics, but it's not something that one cannot pick up. But only thing that it needs is a little bit of brush up on that, and hence what having a mobile, having the seen lectures again and again will actually help. It has its online self guide with the live virtual classrooms, which we are doing right now. A fairly large set of assignments. You're going to cover lots of projects, and I highly encourage you all to attend each of the projects. Do on every project on your own. This is your time to make your skills, hone your skills essentially, right? So that you can apply them in a production ready environment. So take as much as projects that you can. and try to finish them. You'll also have a lesson and project for every course, every lesson, right? This is, and we will go through that each lesson, and then you also have a course and projects, which with quizzes and practice tests and so on and so forth, right? Um, then we'll also have some completion criteria. That is, this is important. The course completion criteria is you have to have a certain amount of presence, in the classroom. You must have, score a certain level of mark, in this case 60%, and your project submissions, and based on your evaluations, you're going to get certified, right? And we will go through that. You might have gone through LMS, the learning platform, but I think um, that's a great platform. So before we start, can I get a shout out from all of you that how many of you are from information and technology background, and how many of you do know machine learning, or even for that matter deep learning? I'm going to give a minute or so that you can respond. All I wanted to know that what is the blend of the class that you have. Do you know deep learning? Do you know machine learning? And what's your background? One liner for all of you would actually give me a sense of what this class comprises of. Okay? Can I have some? Can you guys put something in the chat that what exactly? Okay, fair enough, Rajio. IT background, okay. What about others? Okay, you have IT backgrounds, great. Harpreet, what about others? Okay, okay, very nice. Diverse group, yes. Okay, okay, awesome. Non-IT background, okay. A bit of NLP, yeah. Healthcare, certification in ML done, okay. Very nice. I think overall we have a very diverse group of people, people who have worked in big data problem, people who are PhDs, people who have, you know, are in computer for quite a bit of time, people who are in GIS, spatial analysis. One of my first job was actually in GIS, so I'm very close to that domain itself. Very nice, very nice. Um, and teaching experience. Okay, good, good. Overall, pretty good. Okay, so people do you have experience of machine learning, you have experience of computer science, some have very diverse background. Great, great, awesome. I think we'll have fun, guys. Don't worry. Okay, let's establish a ground rule. Okay, um, okay, great, yeah. So I would like to have so I let's have some ground rules established. I generally like to start on time, okay, and we will be covering pretty detailed, deep topics, and time is of essence. So let's try to attend this on time. If you have any time doubt, as Asha said, please use the chat box, and we will try to answer as much as possible, right? Let's make this session interactive enough. If you have any questions whatsoever, feel free to ask. We will also have a dedicated Q&A round at the end of each, lecture series. But that doesn't mean that you cannot ask questions in between. Please feel free to ask, and I'll be attending to them as and when I can. We will have one break. This is a 3-hour class, somewhere in the mid. It's 8 p.m. India time now, so it's gonna be 1.5 hours from now, which is when we'll have we'll take a break of about 15 minutes or so. Right, as Asha said that we'll have a polling at that time. I'll talk to Asha and set up the polling at that time. You can reach out to the support and community forum for any assistance. There is actually a support and community link that I have to share. Asha has sent that to me. What I'll do is, like, sometime in the break, I will share that link with all of you so that you can reach out to a broader audience in Simplilearn. Great. Okay. World of social media is in. You have to, if you like this series and this Simplilearn's initiative to teach people machine learning, please spread the joy and spread happiness. There are enough social media handles where you can become our advocate and spread the word. Okay. Let's do one thing. Let's just directly go to LMS, the platform on which Simplilearn operates on, and we will actually see that what it is, and experience that. Okay. So let me just go to my browser. Okay. I hope you are able to see my browser, and if you are, please a short shout out will help. I'm assuming that you can see my browser, so I'm gonna just go right to it. So if you see that this is the LMS page that you must have got once you log in, right? You will generally have 3 4 tabs. Self-learning with the first one, and the first section, this self-learning is actually divided into 3 sections. The first one is a it's a self-learning videos where you'll actually find a lot of interesting videos. You can treat them as pre-reads, post-reads, talks about, there are fairly large number of topics all related to what we will be discussing about. You can go through them at your own pace to have a basic understanding on what we are discussing on right now. Okay. I find them fairly informative at any point of time. Section 2 is where we will be focusing on our most of our time. This is actually your course curriculum, lesson by lesson. We will be covering about 8 lessons, and I'll cover the course infrastructure and course in detail, but this is like 8 lessons over a span of 11 days, 3 hours each, right? And we are somewhere here. This is lesson 1, and that's what it is. One of the important things that you have to notice is that the practice labs, the place where you will do practice, is embedded inside this LMS. If you don't know about it, LMS has a Jupyter lab, and it's a notebook environment using Python, and so you don't have to worry about we don't have to worry about installing any kinds of frameworks or bringing up a server to learn our sample code, right? I highly encourage you to look at this video 1.2 and look at it, what you should be doing. Okay, so like this, if you actually go to practice lab, I just before the session, what I did is that I just you can see this, right? I just uploaded all our code and data set here in the Jupyter Lab notebook, and we will be using this extensively. Okay. Though we don't have anything today, but from tomorrow onwards, we will have live sessions and and activities here with assisted assisted practices and all. So I would highly encourage you to go through it if you are not familiar with Jupyter Lab environment. Okay. Okay, so it says that my lab is ready. It gives you the Jupyter Lab environment, the UI, if you're familiar with it. It's a notebook environment, and we'll just give it a minute so that the UI can come and I can show you that how it looks like, right? Yeah, so can you reach out to the Learning Success Manager on this? Um, is it's better to actually reach out to Learning Success Manager on this. Let me just actually also do one thing. Let me share the, yeah, please raise a ticket. Right. Okay. Okay. So, yeah. So sometimes it happens, we just have to restart it, but overall we'll come back to this. Now I think it's coming up now. Okay, just wanted to show you that. We'll come to this, don't worry, but but what is important is that just be aware of that everything that we will do is here only, right? Okay. Um, this is your live class. Okay, so it's finally coming. I just wanted to show you guys. Yeah, so this is the Jupyter Lab environment, guys, and please be aware of that. This is the notebook file. If you know what I'm talking about, this is where we'll be executing all our code. It is just a easy common environment for all of us to work on, so that the configuration of each of our laptops or machines that you are working on does not impact us, right? And we can even raise issues if you actually do see things, and Simplilearn will help us to solve it, right? So this is what we'll be using it. The reason it is important is that from tomorrow onwards, we have these assisted labs, and I will be running code along with you on this. So highly encourage you to go to this specific section of your lesson 1 and have a look at this video, right? How do you access practice lab once, right? Okay, great. Apart from, so how do you join your classes? You have all joined the classes, hence I'm assuming that you've already got already are aware of it. This is where you can actually click on and directly come to the WebEx session, and your assessment essentially is, you can see the assessment details here. You have a project, 3 projects, and you have a couple of tests that you can attend to, and all of them are mostly gradable, right? Awesome. And after you finish all those things, the criteria, your certificate will be hosted here, which you can download it whenever you can, right? Any questions before we actually go to the course introduction? Awesome. Let's go to the course introduction. Okay. So I'm going to close this. I'm going to open a separate PPT. Right. Thank you, guys. Thanks a lot. Okay. So let's come to our course, and the course that we will be doing is deep learning with TensorFlow, right? And what is the objective of our course? The objective of our course is that by the end of this, you should be able to understand what is neural network, okay, and how it is helping to solve pretty complex problems, right? Frankly speaking, neural network is all across us, and only someone with a knowledge can appreciate what it's doing to our life. And this is a chance for you to understand that and become master of it, and eventually we help create such systems which will be beneficial for all of the humankind and so on and so forth, right? You'll also be able to configure, right, these algorithms, this kind of systems, and how to train this, right? Neural network essentially at its core is a way to train or way to model intelligence, right? That is what we are, right? We are in a business of modeling intelligence, isn't it? And it is just and you will be becoming someone who can actually configure these algorithms and train it appropriately in your environment. You will also be knowing what are the various frameworks of creating. Okay, you'll be knowing, in this case though, we will be focusing on TensorFlow, but that is not all you have. You also have in the world PyTorch and Thenios, and there's so many other things, right? But mostly, PyTorch and TensorFlow are leading the race of frameworks, at least in this case, right? We will be training and we'll be discussing, at least today, what is a framework? Okay, what is a framework? That's a great question, actually. What is a framework? A framework is essentially a tool set which allows you to do your job easily. Like, let's understand, right? If you have to cook, right? The fundamental, suppose you have to cook and you need fire. Do you always have to go back to create fire? No, right? We use a cook oven. So cook oven is a framework to allow us to access of fire. So framework is a tool that we have created and an abstraction that is created so that we can reuse it again and again and again in an easier manner, right? So let me just give you an example. Your operating system essentially is a framework, right? Your WebEx, the thing that we are using, though it's a software, it's also a framework, right? In the sense that it allows us to communicate via this conversation, right? We don't have to do the hard part of doing things. We can use a software, or we can use a ideology to use it and just execute it. That's what a framework is all about. In this case, the framework is TensorFlow or PyTorch. We'll be focusing on TensorFlow, but TensorFlow is a framework which was built in Google Brains team, and Google used to use that framework. And what they did at some point in 2014-15, they externalized it and open sourced it, and then now it's become a leading framework to train deep neural networks. Anything to do with neural networks, machine learning folks here already know, right? What framework you were using while you are training machine learning? Can I get some answers, guys? What frameworks? Yeah, we were using sklearn, right? one of the very popular framework. What other framework that you might have used? Anyone else have to? Is library and framework different? Yes, library is, so a lot of libraries can become a framework, right? Libraries have, yeah, libraries. So Matplotlib, Pandas are libraries, right? Matplotlibs, Pandas are libraries. So you are answering your own question. This is great, right? NumPy is a library. Framework is sklearn. Sklearn uses Matplotlib, Pandas, NumPy, Seaborn to achieve a problem statement, which might require these libraries who are much more narrowly focused. So that's the difference. Scientific Python, yeah, SciPy, yes, right. Okay, great. So today what we'll do is like we will go through this. We will understand why are we doing this. Today is going to be mostly theoretical in nature, and we will go through it. We'll try to understand what is, how to do, how to work with what is LSTM and so on and so forth. We'll try to make us aware of some nomenclatures and some paradigms, and then we'll deep dive, right? What is the prerequisite? You have to know Python, because we will be talking Pythons. People who are not aware of Python, I think you should actually, it will be helpful if you can actually do some refresher course on Python. Python as a language is fairly simple, okay? But in its simplicity is actually helped and fueled a lot of things, because fundamentally whatever is simple, you can do a lot of things with such things, right? So that's what one of the reason Python is used, because it was simple enough. But that doesn't mean that Python is the only language used in the framework of machine learning, large scale machine learning in really high, really high end environment, like in Tesla they use C++. R is good, but it is difficult. R is focused on statistical aspect of it. You cannot do neural network on R, right? And I think you cannot do neural network on R, right? Because neural network and deep learning is a different type of beast altogether, right? You need certain amount of things to make it right? You also need to understand what is the term called as machine learning, and why are we trying to learn? Why are we trying to teach machines? And these two are very fundamental in nature. I think this is something that will help you to take the best out of this course. Okay, let's look at the overall course outline. And what are we going to spend over 11 days or so. Today is the first one where we will focus on artificial neural networks, and we'll try to understand what is this, okay? What is the history of it, and why does it exist, and on almost theory aspect of it. It is important to start from the theory, because to really truly understand something, it's important that you understand the historical significance of it. There's a question there. Is NLP also covered in this course? No, not in this course. This is a deep learning with TensorFlow. I think NLP is a separate advanced and deep learning. Computer vision is also covered in a separate course, not in this. Yeah, okay. The second course, which is tomorrow, we will actually go deep into the usage of deep learning at a use case level, right? We will try to unravel this thing called as neural and networks, and how does it actually help us, and what else you can do about it. Can you guys hear me? Is it possible? Can my voice? Yeah, okay, fine. It's clear, right? Okay, clear. Okay, right. Thanks a lot. Okay, on the third day, what we will do is we will see the deep neural networks and its tools. We will actually go into the framework. And in fact, tomorrow what we'll do, we'll actually build a base neural network without any framework whatsoever, with normal Python, okay? And we will see that what are the tenets, what are the smallest component that one can build, one have to build to qualify something as a neural network. On the third day, we will actually talk about tools. We will go to different frameworks. On the fourth day, we will see that how to optimize a neural network, how to tune. What do you mean? How can you interpret something like this, right? One of the boon and bane for both these kind of things is that neural network is so-called black box, and we will see why. An interpretability of something has happened and why something has happened is important, right? If you are in machine learning world, if you have experience, you always, and if you have actually deployed some things, it is good that you have deployed, but can you question that can you answer the question that how did it work? Sorry, why did it work? It is working. You can say that, okay, you see my prediction is 98.2%. And but then someone asks, your manager will ask that, okay, can you tell me why it is working? Or can you tell me that for the cases where for the 2.2% that it did not work, why it did not work? So you need to be interpretable, right? You need to be able to answer questions, and we will see that why it is so tough and what are the things that we should be doing. Like any other machine learning algorithm, you have to tune it, you have to feed it, you have to babysit it in a way that it can actually give you the best performance that it can, and to solve your problems, right? And we will look at it on day 4. Right? Okay. Sorry, which one would you want me to repeat, Sachin? Sachin? On the day 4, on the day 4, we will actually look at interpretability, optimization, and tuning, and then we'll see that how do we babysit things, how do we optimize it to make use of things. Okay, right. On day 5, we will actually move to a specific type of neural network, which is called a CNN, okay, convolutional neural network, and we'll see that its impact on doing things with stuffs with images, right? On day 6, or the sixth part of course is not going to be exactly day 6, because it's possible that we will be spillover, and we might not be able to finish a course in a time frame that we've been given. But on the 6th course, we will actually take something called as the recurrent neural network, which is generally used to model sequential data. We will try to understand that what is the sequential data, what is the time series data. We will not be talking NLP, but you should also understand that recurrent neural network has profound impact on NLP and natural language systems, right? As with its, other things. Question is that can we use TensorFlow instead of CNN? Again, TensorFlow is a framework. Okay, CNN is a architecture and an algorithm. So you will see a CNN implementation in TensorFlow. So there are two different things. TensorFlow is a framework which has CNN implementation. So inside this, you have to use CNN. Yeah, CNN is an algorithm. It's the core algorithm via which one can get some stuff. So in TensorFlow, there is a CNN implementation which one can use. Okay, and we will end up with the great algorithm called as autoencoders, and we will learn what it has done. Autoencoders have it's a great way of doing unsupervised learning, and we will see that the flavor of deep neural network or neural networks using autoencoders on the last day of there, right? Okay. Got it. What are the projects we will do? I'm not sure exactly whether these are the projects or not, but you will be actually doing projects with ANN, CNN, and RNN, and definitely with autoencoders. I think they are the same projects, yeah. So there is a PUBG project and a lending club loan and data analysis project that you have to finish, and this will require Python for sure. Course completion criteria, we have already discussed about it. I will quickly discuss, which is we will attend all the live virtual classes. You have to attend all the live virtual classes, and it's a minimum of 78% you have to score, and you have to submit at least one course and project, but I highly encourage you to complete all of them for your own benefit. Okay, got it. So let's do one thing. Let's quickly go down to our core session, which is about learning about So introduction to AI and deep learning. Let me be very clear that I'm opening the correct things. And if you actually see that, now we are starting our journey. My pace is slow? Is it too slow, or is it slow, or is it okay? I'm intentionally going a little slow. But if you feel that it's actually slower, okay, awesome. I got a lot of goods. Thank you, guys. Thank you, guys. Let's start. Okay. Okay. So by the end of this course, and we'll try to complete this by today. Today is mostly, as I said, theoretical in nature, and our objective is to try to understand the concepts around it. We will not do any hands-on, but we'll try to see that how we can achieve, how we can understand this. We will try to understand what is artificial intelligence, deep learning, and deep learning, both of them. And maybe one of you can actually answer what is ML, AI, deep learning. There's so many jargons, right? I hope you have to have a very clear idea and where does what ends, okay? And we'll go through that. We'll also go through a history of AI, and we will see that if not one of the oldest, it's actually pretty old, okay? And we will see that what it means. And there is a thing that I keep on saying other learners, and I will state that is one of the oldest computational field for a long time. Okay, if you and we will see that, and since it's old, people think that it's very new. It's actually not. Okay, people have been researchers and mathematicians have been dealing with this for a long time, and we will see that its journey over the years. Okay, we will see some success stories. We will discuss a specific use case, and this is a discussion point where we will discuss via slides only that how does and what is the importance of self-driving cars, right? And how does an algorithm like this, which is called as an object detection, uses deep learning to help and drive cars automatically, right? It's one of the hot thing with Tesla and Mr. Musk, right? It's a pretty good use case study. We'll also understand one more use case on LSTM using sentiment analysis. I'm not sure whether it is there or not. We'll look into that. Okay. And of course, we will discuss a typical life cycle of a deep learning project. Any project of any magnitude, for that matter, requires a plan. When you actually go and deploy one of these models in production, you would also need a plan to execute such things, right? So we will see that what a typical life cycle of a deep learning project looks like. Okay, let's start. So what is artificial intelligence? Let me actually put the chat box here. So what is artificial intelligence? What is artificial intelligence? It's actually a branch of computer science, right? What it tries to say is what is the word? If you can unravel these things, right? Let's understand what it is. Artificial intelligence is a branch of computer science that attempts to simulate laser pointer, okay, that attempts to simulate human intelligence. Okay, so basically our objective is to create an intelligence artificially, and of course, given the fact that we are saying that human being has intelligence, probably the most intelligent living thing in the foreseeable universe, right? The universe that we can see, and we are trying to simulate the most intelligent being that they are living, right? That's what artificially. And the only way that we can do something artificially is via robots or some sort of discipline which allows us to do that, and computer science happens to that that branch, right? So in a way, you're trying to model human being intelligence into machines which can actually think, decide, reason like a human being does, right? We all agree one thing, right? Human beings are one of the most intelligent beings, right? That's been proven, right? We might all have pets at home, and we realize that they have very basic needs and they have very basic input output, right? They can only do so many things, but human beings can do so large amount of things in spite of their smaller sizes than other animals, right? So definitely intelligence is playing a large role there, and hence it's better to actually copy someone who's really good than copy someone who's not that good, right? So that's why we are trying to model a human being's intelligence. And then you will see that in a lot of things, biologists come and they try to map brain, and that's what we will see, that we try to copy what's happening inside brain into these machines, right? The three fundamental aspects of intelligence, right? You To have an intelligence, right? If you are in the business of modeling intelligence, you must be able to learn something, right? And human beings, if you see, are a continuous learning engine, right? Um, you should be able to reason, right? Whatever you have learned, you have to apply and reason about it, right? And that is not an easy task, right? Reasoning is a continuous process that we do, and you have to, of course, make self-correct. You like to even self-correct, you need to understand whether you made a mistake or not, right? Making a mistake in machine learning is called what? Can anyone tell? If you make a mistake, and in that, if you have to analyze right error, what is the right? If you are making an error, so what is that called as in machine learning? What algorithm defines that? Any machine learning folks here? It's called as a loss function, right? A loss function define how much your learning has errored from the actual thing, correct? Essentially, or cost function. There's a various names to it: loss function, cost function, error function, right? So, but the idea is that one needs to learn from something, and that something is nothing but data. And from the data, we make certain sort of rules, and that rules becomes our basis of reasoning. And while this process, we continuously try to self-correct, right? We make mistakes, we make smaller mistakes, and adjust ourselves, right? That is that is essentially intelligence, right? So for a machine to become a classified as an AI, it has to perform these three tasks, right? Right. I always say that now one thing is very clear, that this is what we are doing. Let's look at history of AI, and you will see that in 1950, right, Mr. Alan Turing, and if you know about this, I strongly suggest that you should go and do it. There's a movie on Alan Turing called as The Imitation Game, right? In fact, the paper was that he made in 1950 was called as Imitation Game, where he tried to describe that can machine think, right? And he basically ideated a question, and a paper and a model saying that this is how one can test whether a machine can think or not, right? This is 1950, and if you see language, or if you see any kind of test nowadays, they will say that it has passed Turing test, right? It has passed Turing test because and that the test that he has formulated. This is in 1950. In fact, if you should know this, there is, I think 3 years back in 1947, there was a machine which was done to make translation work. Okay, some machine, right? So this is not a new field, which is like ironically, right? This is 2022, like it's like eons, right? This is not a new field. People have been trying to take a stab at it for a longer time. In fact, much longer than proper computers have even evolved. It's so far, right? And hence there has been a lot amount of research and effort that has been gone into building and putting into this idea of modeling intelligence. So if someone says that this is something new that has come out of the blue, please be aware of the fact that that is not true. Okay, it's one of the earliest problem statement that human being is trying to face. Right? Yes, the Enigma machine. Enigma machine was used to, you know, the Enigma machine was used to create, break those cryptographic signals from in the World War II, right? Yeah, you should see that imitation game. That's a good representation. In fact, if I have to see this, I was actually reading through it. I have read this. So this is his paper, okay, original paper. I will drop you guys a link, and this is not available anywhere else. But I mean, I think it's available in many places. But you should read these things. English language is very simple, but it's profound to understand this has happened in 1950, and we are still discussing about it, right? Um, right. So, and somewhere in 1955, right, a gentleman, my name John McCarthy, he was attending a conference in Dartmouth, and he coined this term called as artificial intelligence. I will share that link. Definitely, I will share the link. Okay. He not only coined artificial intelligence. In fact, if you know, let me just do one thing. Uh, if you know about him, he has actually, sorry, he has actually, sorry, he was the father, or he was the one who actually created Lisp programming language. And I was lucky enough to actually program in Lisp. There was a software called as AutoCAD, okay, and it is still there. You can program Lisp. Lisp is an awesome 4G language. All the software programmers here, right? They will know that you have to write the operator before it. It was really weird. But he was the author of Lisp programming language, and he was the first person in 1955 to coin this term called as AI, or artificial intelligence, at least in the known world. And then somewhere around, after that, about 20 years, from 56 to 74, this era of internet, right? With DARPA been trying to solve computers which can solve algebra problems, and if you have seen that computational mathematical computation was important because NASA was trying to send a spacecraft to moon, right? And they needed lots and lots of computing power. They were using human computers, as well as there was a need to get computers. So this whole era was about developing more computers, more computing power, which can solve algebraic problems, theorems. Can learn to speak English. In fact, one of the first chatbot, okay, Erica, if I'm not wrong, I think its name was Erica, was somewhere in this during this period, and you should see that. Okay, it's actually a chatbot that was done in that. So it's Erica, yeah. So that was done in this period, by the way. Okay. So this is not again something new. What we are learning now is on the back of the shoulders of a lot of great people that has happened. After this era, right, from 1800s, 1980s to 2000, there was a rise of a lot of machine learning. AI as a science have evolved, and so on and so forth. But somewhere the hype of AI has been always there, but it was never able to deliver. If you have known about this term called as AI winter, right, which typically means that, okay, AI, when will this intelligence being, or artificial intelligence being come, right? And it never came. So people sort of gave up. While there are some people who are actually, you know, who had a belief in that and they continue to work on that, there's a majority of people who thought that AI winter has come, right? And whatever is this is gimmick, nothing will work. But in 1986, neural network returned to popularity after that winter, okay, and then there was a major advances in algos per se. And now there's also substantial rise from the PC era has increased the computing power from whatever is this, and Moore's law was at its peak at that time. Okay, it was, I think that they say that it was not 18 months where the CPU was doubling, right? It was a much shorter, right? If you know what is Moore's law is, right? AI as a science came around 1995 with vision, language, and information mining techniques gaining popularity. One thing was very clear at very early, right? If one has to model a human intelligence, you have to have you have to build the ability to see something, right? The vision, the power of vision that a human beings have, and the power of language, right? These two, basically, vision is there with a lot of other animals as well. In fact, there are animals which are which uses vision as their main, like they have more powerful vision cortexes than human beings, right? But one thing which truly stand out for human beings is actually language, isn't it? So was very clear that, okay, we would need to work on these things, vision, language, and how do we get information, how do we mine them, and there was a focus on that. 2006, where if you actually see, this is pre-iPhone era, okay? iPhone was launched on what, 2007, right? If you guys remember, the first consumer cameras which offers face recognition software. Nowadays it's very open. You open your iPhone, you open your Android, whatever phone you have, right? The moment you go to that camera, it will draw a box to your face. At the right, isn't it? So that's what. That's not nothing but a face recognition AI model which can detect that there is a human face, right? And it draws a bounding box around to it, and we'll look at that. But 2006 is when we started seeing that, right? If you remember this, around 1997, this was pretty big news, and I remember this distinctively, where Gary Kasparov was defeated by, IBM's this Deep Blue chess computer, and it was all over the paper. Gary Kasparov, was it's legendary, right? This report was, and though the Deep Blue system was not a true AI system, or neither a machine learning based system, if you actually read the paper, but it's pretty intense to see that a machine can actually beat a world chess champion of his caliber, right? This was in 1997. Pretty interesting, right? And if you see nowadays, right, AI is everywhere, right? The keyboard that you type. Do you know what exactly is that? Typically the keyboard that you use, it's actually a machine learning model, right? It predicts that what will be the next word or character, and it actually preempts so that your focus will go there, right? The Google Assistant, right? Or what else we have from Amazon? What do we have that? What do we call from Amazon the conversational assistant? I think it's Alexa. Yeah, Alexa, right? It made a lot of waves. Then in iPhone Siri, right? These are all very now. It's like in every mobile you have it, right? In fact, our mobiles now are yeah, Bixby is in Samsung, right? And our mobiles are much powerful than at that time of whatever the supercomputers were, right? So it's all over the map, and all of these are run by neural networks. Okay, machines which are built using deep neural nets, and they have now shrunk in so small sizes that some of them can be actually put into your mobile, right? And one can use that, right? You see this paper, right? If you're not wrong, there's the Indian company Mitra who was also developed a bot. Especially, it was very popular while COVID cases, right? While COVID, right? Hospitals were employing it to deliver things, and you can ask it, and it will try to answer what it can, right? In fact, we will discuss about this when we discuss self-learning. Tesla is trying to get, do something on making up true humans, true robots, right? Sony did something. Japan is very technologically advanced country in its way, right? Robots or robotic dogs, if you know, right, have been there for a long time, and they used to respond to your gestures, right? And if you cuddle something, there's some rules that they have done where it can respond to certain amount of things and mimic a dog, right? Da Vinci surgical system is pretty revolutionary, right? It uses deep learning and AI to make high precision. I know personally someone who has gone through this. What I was told is that if the quantum of blood loss during that particular operation was suppose 1 liter, and it was a very complicated multi-hour operation using this particular Da Vinci surgical system, the blood loss was 50 ml. It's actually less than what we normally take, right? So the precision was so high. So I know it, personally, that someone has actually been, so this kind of systems are all real, practical. It's no more in the air. It's all around us, and it's in our interest from a technology standpoint to understand them much better, right? Okay. So what can AI do? What can it do, right? Here are some of the problems which we know machines can solve it fairly well, right? And if you see, right, they can solve superhuman tasks which are very challenging, tasks which are, which might lead loss of human lives, right? And you see these applications in military, right? You have these UAV drones, right? Unaided aerial vehicles, right? And they can go to really dangerous situations and do something about it, right? So those are like nothing but superhuman tasks, right? Tasks which are repetitive in nature, right? Right, again and again. But you cannot make it's repetitive. That doesn't mean that it is error prone. It should be error prone. But human beings generally, what happens is that we have one of the biggest problem is that we will lose energy after some time. We need rest. Machines don't need rest, right? As long as they are connected to some sort of energy power, right? You are fine, and machine can continue to do repetition of task without making any error whatsoever. And if you have programmed it well, right? So they're great at doing repetitive tasks, right? Data intensive tasks, right? If you have extremely large amount of data, human beings probably will not be able to process a very large amount of data, right? And this is something new that has happened probably what 20 years. We never have we had this problem of large data. I think people realize that there is a problem of large data, but there was no access to large data. Nowadays, the access has quadrupled. It has blossomed, right? There's too much large data around, and data is easily accessible and easily producible. Hence, these systems are, you know, coming in off age, is what I can say, right? So data intensive tasks are extremely, AI friendly. And if you have a task like this, apply AI, you might get a better result than anything that you can think of, right? Advantages of AI, we can go through it clearly, right? If you have a systems, if you have not coded badly, if you are not a if you have not put a bug in your program and your error rate is low, you can actually get incredible precision, right? Like the Da Vinci system. Digital assistant, chatbots are everywhere. If you see, right, the last 6 years, right, 2016 onwards, abundance of chatbot is left, right, and center. Everyone has a bot, and you will see that models which are coming with really large and highly accurate answers, right? They're all machines, right? Hostile environments, we've spoken about it. Repetitive jobs, right? Medical field, right? There's a huge medical applications, right? COVID detection, X-ray detection, pneumonia detection, pure play, image detection problems, right? Um, how do you put a bug in a system? Oh, you should talk to a software engineer, right? Any software engineer live for bug, if, right? So how do we put a bug in a system? Because I think it's a great question. Think about it, right? Who writes the code? Okay, all these algorithms in the world is awesome, but still, who is writing the code? The code is written by human beings, right? And we know one thing: human beings are great, awesome, intelligent guys, but they make mistakes. Whatever they do, they will make mistake, and then they will fix the mistake, right? Any fundamental of a learning system is what you make the mistake and then you fix the mistake. But you have to make a mistake, right? Or is to be human, absolutely. But what at what cost? So at what cost? At some point in future, the day when AI will start writing code, there will be no mistakes, right? At some point, it's not very far. If you know, GitHub has a tool called as Copilot, right? And they are advertising left, right, and center, right? Like that, they have, with OpenAI. You say it something, it will write the code for you, right? So that is where it's going. Where Copilot is scary. It's still its nascent state. I have seen a much advanced version of a Copilot, and it works. Okay, in cases like that, it really works. Okay, and if you are someone who, like me, has been coding for a long time, if you remember, Microsoft has a thing called as IntelliSense. It used to detect. Even that also is good, but they have taken it very far, right? So the day when computers are writing codes for computers, I think that's when I think it's done. That is a point of, I think, inflection, that okay, it's now done, because at that point there will be no error. right? Because everything has to be learned, right? So that is what we are achieving for, right? No breaks, right? Machines, like unlike humans, don't need sleep. And if you, yeah, probably you wouldn't need programmers as well, right? If you are a Terminator fan, you know, right? What is that place where all the machines used to be there? There's a place, right? Skynet, yeah, Skynet. Skynet will happen, right? That's what they said. The singularity will happen, but it's not all scary and all. If you see, right, this advantages of AI where you have more machines than humans, and if you are someone who's following Mr. Tesla, Elon Musk, and Tesla, what they're trying to do is like they're trying to liberalize labor by building these bots or human-shaped robots which can actually do your job and which can actually be a companion. What he says is that if that happens, that will be a time of abundance. Like human beings don't have to do menial job, we can focus on what we can focus on, and the all everything else can be done by these machines. And we have so much time in the world that, and there is no labor shortage, which means if there is no labor shortage, the whole economy will be very cheap. I mean, it's pretty revolutionary. I think you should guys see that, right? It's called as Tesla bot. He's supposed to launch a demo this month, but it's postponed to September, I think, because of some reason. And I think you should see that. It will change your mind the kind of thing that is happening there, right? There's clearly a lot of advantages of AI. Okay, one can hardly list all of them in one place, right? However, it's not all hunky dory and glory, right? There are significant challenges in AI as well, right? It is not easy to model human intelligence, right? We are a multifaceted system, and some say that we don't even understand human brain at the way we can model it properly, right? Which is true, right? It's very very difficult to capture all our traits, right? And it will take some time. It's not there yet, but it will go there, but it will take some time. If you're aware of this company called as Neuralink, this is one of those other companies of Mr. Musk, where he's trying to map the human brain, right, by putting a chip inside your brain, right? So all those efforts will actually, at some point of time, will help us and will ultimately be feeded into the intelligence bit as well. It needs continuous development, okay? And if you see that there's a domain which are very lucrative domains, most of the money and most of the focus lies there, right? There are other places where the focus is not there. By the way, someone has said agricultural sector. You should see this company called as Cropin, and in fact, there are many other companies who are using neural networks in agri-tech like anything. Okay, agri-tech is one of agriculture and agri-tech is one of the hottest bet to apply neural network. What they're doing is like detect not only bad crops for like millions and millions of crops, right? Like acres and acres or millions of acres. The machine can go to each and every leaf and can detect whether the leaf is bad or not instantly. So it's so precision, high precision systems. Yeah, I think agritech is very very booming. Okay, and this company, especially Cropin is an Indian company, is doing pretty good on that. Okay, ability to respect with diversity of domain problems, right? We've not yet, AI as its moment is solving one problem at a time. Human beings are not that, right? There's a term called as AGI, called as artificial general intelligence. It's not, we have not reached there yet. Okay, it will be some time before we reach there, but our objective is that at some point we will be reaching that. And what is AGI? Why are we human beings called as AGI systems? Because you have different, you don't have two brains, you only have one brain, right? And one brain can actually do many things, right? While I'm talking, I'm actually moving my hand and I'm thinking what is my next slide, and I'm also checking my time. There's a lot of things that is happening, right? And also check, checking whether there is a question on the chat. Lot of things is happening, lot of different things. If you now have to ask a AI system to do it, you have to have different models. One has to look at the chat window, one has to look at that, and then someone all has to make a meaning out of it, right? So we are not there yet, but you know, I think it's not that very far, and the pace at which things are going. It's also a very high cost of R&D and production. These models and at production scale requires eons and eons of training energy to run. It depends directly proportional to the data you have. Since you have a lot of data, you might think that you can put a really large system, and we will see that how large. There is no limit to systems which are very large. Okay. The other important aspect which is not listed here is actually interpretation, right? In fields which are highly critical field, right, where one mistake can cause life and death, and you have a risk. You have to say that who is responsible for that mistake, right? um, that is critical, right? That is the ethics angle of AI, and ethics in AI, if you see, right, is a big topic now, right? There's a lot of debate going on that if AI is doing everything, then is AI responsible for the failure also, and can we change the laws, right? Because human will say that it's not my decision. There's a self-driving car which actually bumped and killed someone, right? If you are aware of the news, and you can easily blame that it's the AI system, it's not my problem. Even if I own the car, it's not my problem, right? Who owns the risk? That's how the ethics part of it is also not very clear right now, and who does what when, right? And that is where also it gets little tricky on real-time use cases, right? Awesome. I'm going to take a 2 minute short break if you have any questions. Before we do a little bit of recap on machine learning, because it's important, and then probably we can see wherever it is. If you have any questions, please shout out. If you don't have, we will just continue. Is there a concept of overfitting in AI? As in you're talking about overfitting a machine learning model. Yeah, of course. So what's AI? Okay, let's do one thing. Yes, yeah, of course. So the thing is that let's do one thing. Um, let's actually see this. So what is AI? AI is the full landscape of things, right? Like our objective is to get um, intelligence from artificially, and then we have machine learning. Machine learning's objective is what? What is the difference between AI and machine learning? We use it in same line, but you know, effectively they should not be used in same line. Okay, AI and ML. So there is an and. Actually, we have to put an and. Machine learning talks about data and its internal pattern. AI talks about causality, right? Like you're taking a decision, right, based on what you have learned, right? So that is and using that what you are doing, that's intelligence. So there's a little bit distance differences between those two. So when you're asking about whether there is overfitting in AI, you are literally asking the algorithms which power these neural nets, do they overfit as well? Yes, there's a high tendency of overfitting as well on them. Okay. In ML, which regressor is, so ML is, of course, yeah, everything is intelligence, everything is artificially intelligence, and then we have machine learned, and then deep learning is part of ML. In fact, there's a diagram somewhere, we will come to that. There's a question there also, in ML, which regressor or classifier we we have to revise for DL. Uh, as in, like, from a revision point of view, what will you revise? Neural networks are a different class of networks. Okay, you will have to revise small concepts. It's a new algorithm altogether. Okay, if you think that you can use SVC directly or SVM, support vector machine, which was the topmost algorithm of traditional machine learning, right? From using the and let's start on that. Since we are discussing ML, let's actually discuss and see that what is this is trying to bring us, right? So what is machine learning? We know that machine learning is comprises of these three things, right? Supervised, unsupervised, and reinforcement learning. Can anyone tell what is supervised learning? How do you define that something is a supervised learning? Result is known, okay? Result is not known. Result is the output of something. Yeah, we know the historical level. So result is the output of something, right? You have to say that we know the history of it, which means we have a target, we have a known level, right? We already know something, and using that, what we did, we can build a hypothesis. Essentially, what it means is that we can, um, we know the history. Whatever has happened, that is known to us, right? What is unsupervised learning? We don't know what has happened, right? The level is missing. All the data is exactly there, but we don't know what is the historical significance of it, right? And hence it is difficult for us to apply a historical a history to do it, right? So supervised learnings are generally predict next value. It's always task driven, right? Unsupervised learning are higher, like it's data driven, right? What is reinforced? Yeah, you have to guess categories. You have to guess, not guess. I mean, guess is probably a loose word, but essentially, yeah, you have to derive. You have to extract. You have to identify categories or clusters or patterns for that matter. For an unsupervised learning, right? Human beings are both unsupervised and supervised, right? Many a times, are we truly unsupervised? Like, have you ever started anything without knowing nothing? Like, have you ever started driving a car without knowing any knowledge of a car? Yeah, I think probably not. Probably yes, I don't know. Language is something that when you started speaking something, right? I think there was some initial construct that you might have. Uh, and I think it's not clear to me, right? There was a question there about technology. I might have missed it. Can you actually can okay, if I want to know new technology, what should I do? Okay. Um, we'll come to that. I think I'm not able to understand the question, but we'll answer to that. Okay. Maybe sometime in the end of the session we'll look at that. Right. Um, but the question is that, are we a truly unsupervised beast or a supervised beast? I think we are made of both, right? There are many cases, many things. If there is very unknown situation, one thing is very sure, that we don't need millions of data to learn, right? You never spend years or years on teaching yourself riding. 6 hours of driving was more than enough. 30 minutes of the driving test was more than enough to get your license, and then you started knowing enough of it, right? So maybe this idea that we always need large data might something might want to be relooked at some point in time. I think people are looking at it for sure, right? So what is reinforcement? Okay, we are very familiar with supervised and unsupervised. So what is reinforcement learning? Reinforcement learning is a, yeah. So what is that? It's essentially a teacher and a student kind of a concept, right? It gives you, like, it teaches itself. Like, it will, if you make a mistake and you penalize it, you do something good and you get appreciated, and that's how, based on these two things, you actually try to learn. So this is also one way of learning, and to say that this is how we learn, right? When we were babies, right? When we used to make mistakes, and we will be gifted with something. Sorry, we will be, you know penalized, right? And sometimes, either our parents will penalize, or sometimes environment will penalize, right? If you touch a bucket of hot water, you know that it's hot, and next time onwards you will never touch it, right? Because you know that it's boiling and it might hurt you, right? So that is what is reinforcement learning is all about. And however, we will not, reinforcement learning, I think in discipline learning, is a dedicated, advanced, deep learning topic. We will not be covering it here, but it's good to know that this exists, right? Okay. So let's look at a little bit on supervised learning, as all of you said, right? The In this case, I already know I have samples of various cats who look like cats, and I have trained the machine how to detect something of a cat, right? And I have trained the machine, and output of a machine learning is what? Output, or basically, what is a machine learning learning algorithm fundamentally is? It is nothing but a function, right? And based on the traditional machine learning algorithms, if you have heard of this, there are two types of traditional machine learning. So there are two types of machine learning algorithms. One where we know the structure of the function, right? The function as in the mapping function or the learning algorithm, right? You are using a line to draw the decision boundary. That is called as linear regression. You are using a line or a hyperplane or plane to clear the red versus blue points. That's using logistic regression, right? So that's a line, right? And so on and so forth. So you know the function's shape and form. That is called as parametric functions, where you already are aware of how the function behaves, how the function on its own might look like, right? There are other classes of functions or learning algorithms where you don't know the shape of. Can anyone tell me can anyone name a function where you don't know the shape of a function, which is actually very popular in machine learning algorithm, traditional machine learning algorithm? Any decision tree, right? If you take any decision tree, if you remember decision trees, they build flowcharts. Remember, they ask if constructs, and then they will build flowcharts. So they don't have a form factor. They don't have a form of a function. They build as the data comes, right? Yeah, any kind of you know this thing decision tree, whether it's random forest or whatnot, right, is a non-parametric function. And at this point, it is better to actually tell you that sometimes it is better to actually have non-parametric function than parametric function. So I'm using two jargons here. Jargon number one, it's important for you to understand, is that called as parametric function. Parametric functions are functions which are used in learning algorithms where you know the shape of a function. The function formula you already know, you are aware of it. It's a formula, right? It's known to you, right? Linear regression or logistic regression and others, right? Decision tree, there is no formula. The construct is been built. Similarly, neural networks are also part of non-parametric, right? Where you do not pre-decide what is the formula to divide things, right? So this is the core fundamental of a learning algorithms. Okay, so there's a question there. In supervised learning also, the error is reduced by optimizers. So yeah, absolutely. So any learning algorithm, you take any learning algorithm, right? How do we learn ourselves? We make that mistake and we adjust ourselves. Remember, AI has three parts of it. We have to self-correct. How do we self-correct? The only way we can self-correct, if we know that we have made a mistake and then we correct, right? Knowing the mistake is nothing but a loss function. All learning algorithms will have to have a loss function, right? Okay, I'm going to put a star here. Not all have loss functions. There are some learning algorithms which does not have a loss function, but we will not go through that. For now, let's understand one thing. And by the way, they are called as GANs. But for now, all learning algorithms has to have a loss function. I need to know where am I making the mistake, right? Or else how will I correct? So the only way to know is a loss function. And all supervised learning algorithm, be it your linear regression, SVM, naive Bayes, you know, anything, decision trees, everything has a loss function. Neural networks all have same loss functions, right? Optimizers are the how fast can you reduce the loss. The question is that do you take 3 years to ride try to teach yourself riding a car? Will you take 3 years? Will you take 6 hours? Up to you, right? It is better in your thing if you write fast because there is not infinite time available to you. So optimizers help you to reduce how soon can you learn, hence reduce the loss. Repeat these points. So the point that I'm trying to say here is that there are two set of functions. One is called as parametric function and non-parametric functions. If you already know what is classical machine learning, okay, and let's look at some of the algorithms, right? We will see that. Let's look at, we know this, these are the supervised learning algorithms, right? Linear, logistic regression, support vector machine, NV, naive Bayes, decision tree, LDA is strictly still supervised learning algorithm, right? All of this has a function except decision trees. You already know the function and you're trying to fit that function in the data, isn't it? So that those are called as parametric functions. Non-parametric functions are the one which doesn't have a preformed form. They go as a data go, and neural networks are one of them. Just like decision trees, there is some advantage to it. They can model complicated data relationship well. Okay, so that is one of the fundamental reasons why neural networks work. We'll also look at that, and I'll actually give you an example at the end of the day. Why? What is the fundamental reason that it was working? Let us understand one thing also, that in traditional machine learning, before the advent of neural network, support vector machine was the top one. It was able to handle data, pretty complicated, fairly complicated ones well. Okay, of course, at the time there was, compute. We had compute, shortages and all, and support vector machine was, there was a specific part in support vector machine which was heavy and was not able to scale to that level. But support vector machine was the best algorithm to model a complicated data, right? Something must have happened which uh, which helped NN to cross over it, and we will discuss that. Sorry, folks. Okay, and we will discuss that. We will actually go through it. We'll take a small example, and then we'll actually go through it. So we know that there are two types of supervised machine learning problem. We don't have to repeat that. Or if of people who are of non-ML background, and if you're trying to teach yourself ML, so this is what it is. There are two ways of doing problems. One is classification. Are you a good person or a bad person? Is he going to give a loan? Shall I give him loan or not? Will it default the loan or not? Right? Will India win or not? Right? Is it a dog or a cat or a horse? These are all kind of type of classification problem. Right? What is a numerical problem? Numerical problem is what is regression? Can anyone explain what is regression? One line. You're trying to predict what? Number. You're trying to predict what is my salary. Not time series. No, it's not time series. Regression is not time series. Regression is, what is regression? Regression is predicting continuous. No. Okay. So supervised learning has two things. Classification, there are two types of problems that we can predict. We can predict a categorical type of values where we can say that you are good or not. Is it a dog or a cat or a horse, right? And things that's a continuous variables, like what could be the salary of this person given all these features, right? What is the temperature of this place given? These are the various conditions, right? So that's a continuous variable, right? What will be the height of this kid if he has this kind of things, right? So there are two types of, generally they're trying to identify real values, and classification is all about sorting them into categories, right? We try all the algorithms, right? Whatever, anyone who can do classification can also do regression, by the way. Okay? And there are, if you see, if you remember, right? We have multi-class classification as well as binary class classification. Binary class means though there is only one class, but there's possibility one or two, right? Let me see some examples, and I'll actually have to get a better way to do this. Yeah, continuous order. That's correct. Two variables input, that is in linear regression. So inputs can be anything. Features can be your x1, x2, x3, x4. Y is your predicted value. In a machine learning lingo, x is all the features and y is your target. That's what we generally do, right? So you have x1, x2, x3, x4, all the features of the data, and y is your target. That can be classification or regression. And if it's a regression value, you need to do something to do that. Now tell me, machine learning folks, can anyone answer? If you have to do classification, what is the fundamental difference at the last layer? If you have to do classification, what do you have to compute? What is the core thing that you have to compute? If you have to do classification, 1 or 0. Essentially, you have to compute probability of something happening or not, right? You have to compute probability of something happening or not, right? So that is, yeah, not histogram. Histogram is a histogram is not histogram. You don't compute histogram. It's part of visualization. But in classification, you have to output probability. Your output is nothing but probability of something happening or not. In regression, it's not a probability, it's an actual number. It's actual value, right? Okay, right? So what did I miss? So I didn't miss anything. Good, right? So these are the list of supervised machine learning algorithm we have gone through, right? Let's now look at what is unsupervised learning. Where are we on the time point of view? Okay. What is unsupervised learning? Unsupervised learning, sir, very clear. We don't have my y is not clear, isn't it? I don't have a y, so I will have lots of data. I don't know what is my known output, no historical target, but I still have been asked to actually interpret something. So in a very typical pipeline, what happens is that I pass in via these algorithms, okay, these algorithms, and it does something in such a way that I'm able to learn the patterns, right? And what are the various types of algorithm that we have used? We know that we have discussed this something called as clustering, right? And if machine learning folks, can any one of you tell what is the k nearest neighbor, right? KNN also is a classification, by the way. Sorry, KNN. What is KNN? KNN is what? KNN is not. Yes, Why? Okay. Question is that what is KNN? Is KNN part of unsupervised or supervised? KNN is part of supervised learning. KNN classifier. K means is clustering. PCA is clustering, right? What is PCA? What is the full form of PCA? Principal Component Analysis, right? It's a way for you to, if you have extremely large number of features, if you have a idea to reduce the feature, it is one of the things that you can use it for is called dimensionality reduction. Because if you have extremely large number of features, not only your data is large, your feature is also large, you can use PCA to reduce the feature, and it's going to be representational, right? There is also a PCA was developed. You know when PCA was developed? Can you guys? It's actually pretty legendary. Huh? When do you think principal component analysis algorithm was invented? Can anyone guess? Mr. Alan Turing invented 1930. Actually, it was invented before Mr. Turing test, and we still use PCA, right? That's pretty remarkable, isn't it? There is also an updated new algorithm sometime in 2008 called as TSNE. It also does something similar to PCA, but PCA suffers from something fundamental, because it is still a linear model. TSNE also is used in dimensionality reduction, but it uses non-linearity to reduce this. TSNE is also one good algorithm that has fairly recent. There is also one type of unsupervised learning that we have spoken about called as association. Hypothesis. Okay. Hypothesis is what? Hypothesis is, yeah. So let's talk about association. What is association? Does anyone have taken a recommendation system class? I think a priori algorithms, right? Yeah. So if you see a priori algorithms, right, they are covered in association. That's called as association rule mining. If you have a data set, you already have a data set. From there, what is the most relevant items that has come up to it, right? And it is used. A priori data sets are used in association mining. There is also an algorithm called as SVD, and SVD has various flavors, right? Singular value decomposition, right? So in typical algorithms in unsupervised learning, we have k-means, we have a priori, hierarchical clustering, PCA, t-SNE, DV-scan is a very popular one, right? And we have this non-negative metric factorization. Little bit, looks like it is similar to SVA, SVD, but it is not actually. Okay, but they all try to do is like, I do not know my historical target. All I'm trying to do is, I given a data set, I'm trying to find out my patterns out of it, right? So let's come to reinforcement learning. So given that we understand these two things, what does reinforcement learning does? Reinforcement learning is a totally different game altogether. What it does is that it creates an environment. Okay, it creates an agent which is, and it has been given a goal. The agent is nothing but the algorithm. It has been given a goal. If it makes a mistake, the environment penalizes it, right? And if it makes a if it it passes something, in this case Super Mario, so suppose it jumps on top of a turtle or it ducks a fire arrow, right? That means it has achieved something, it has progressed. It will be, you will be awarded something, it will be rewarded something, right? And that's how you learn that, okay, I'm towards the goal of achieving this princess. Super Mario is going a path. The path I have not told him, and I have not told him at all that where to go, left, right, and center. I am allowing him to play on its own, right? However, every time he faces, right, every time he makes a mistake, I penalize him, and that act of penalization is recorded, and then the agent makes, improves that and then acts on it. So a this is a way reinforcement learning agents are trained, and you will see there are a lot of reinforcement learning algorithms starting from self-driving onwards. In fact, a lot of games, right? They are also reinforcement learning output, right? Um, so this is what it is. We have two types of reinforcement learning: positive and negative reinforcement learning. You have to give a desired stimulus or undesired stimulus. Yes, of course, it's a machine learning method. Yes, absolutely. So essentially, the nuances of the core neural networks is used here as well. The core fundamental of a neural network or a neuron, we will see what is a neuron. That core box is also used here, but this goal, you can see that I have given him a goal. I have not historically told. Think about it, right? This is a different class of a problem. I have not historically told, right, that what is good, what is bad, right? I have, basically, it's like that's how you teach a baby, right? You just give him in an environment. You don't tell the baby that don't stand, don't, or else you will fall down, because it is not easy for you to communicate. You give the baby an environment, let it run, and the environment gives the baby a feedback. From there you run. So from that is where your learning process is, right? So that is what is a reinforcement learning. And if you have to, you know, analogy, and essentially the aim is always to find the best path which maximizes my likelihood of winning. The more the awards I win, more for me, right? So that means I'm actually achieving towards my final goal. That is how a reinforcement learning, it's little tricky, but it's also a way of teaching someone, right? So that's, and hence extracting intelligence out of it, right? There's quite a bit of reinforcement learning algorithm already. We will see that, we have Monte Carlo, we have Q learning, we have SARSA, and so on and so forth. But there's a, this is a different class of a learning system where environment gives you a feedback, and you learn from it. Okay. Okay. I think we are at the mid of our time, and yeah, I think it's about time that we should take a break. Before we take a break, what I'll do is, like, let me just, yeah, please take a break, but it will be 15 minutes, guys. And what I'll do is like I'll put a timer. We still have 1 minute, and I'll put a timer. Please be on time. We have to finish quite a bit. We have only just covered 17 slides. We have to cover a little bit faster, maybe. Okay, but we still have time. Don't worry about it. Okay, I will also switch on the poll, and let me just stop the thing, and I will switch on the poll. Just quickly give me a second. How do I? Uh, Sure, guys. I just 15 minutes, 9:30 p.m. right now, 9:45 p.m. IST, 15 minutes from now, Indian time. If there are non-Indians, apologize for it, but 15 minutes from now, I will put a timer. Okay, let me put a timer right now so that we don't miss it out. Google. Yeah. Okay. I've started the timer. I will actually make it visible. Don't worry, guys. I will make it visible. What I will do in the meantime, I'll figure it out how to put up the poll. Please come back 5 minutes and attend the poll. Okay. Thanks a lot, guys. We have exhausted our 15 minutes. I think in the interest of um, everyone, let's give it couple more minutes, and then we'll start. Okay, we have quite a bit of things to capture, but I think what is this? Just one second. Okay, and the polling is now. That was a timer, guys. Okay, Google was reminding me that 15 minutes are over. Okay, let's give us two more minutes, 3 more minutes. Let's give it 4 more minutes. 9:50 we start. Okay, shall we start, folks? Let's start. I think we have about 1 hour 10 minutes to go. I would like to finish things in time. Fine. Now that we have understood what is ML and um, can you teach us how to raise? Yeah. Okay. I will do that. Acha. Okay. So now that we understood how ML versus DL, so we recapped what was machine learning, and just for the interest of our time, let's quickly go over, what is this deep learning, how it is different than machine learning parlance. Okay. Um, what we'll do is like we will quickly run through the slides to some extent, and then we will actually take at the end of the session some of the questions, and so that we will actually make best use of rest of the time. So you can see in a typical machine learning pipeline, what happens is that you have an input, and there is Lot of effort that happens is that um, a lot of effort happens which is focused on feature extraction. A machine learning pipeline on an algorithm is as good as the features that you provide. That is well understood, right? What the problem that you're trying to solve. And this phase of feature extraction was a lot, right? You can actually use human feature extractions techniques, and as well as some of the other known feature engineering techniques like machine learning, to which was then fed to the either a classification or a regression model. The main difference that deep learning actually brings is that on a very high dimensional data, since the data points and are very high dimensional in nature and extremely large, this exercise of feature extraction by human beings gets really difficult, right? And many a times we also don't know what to tell the machines what to do, right? Deep learning or even for the neural networks are specialized in this process. You can see the feature extraction is in fact embedded as a part of these algorithms itself. These algorithms are so specially tuned that given a data set, they can derive and extract latent features, hidden features, which are difficult for a human beings to comprehend, right? So one of the core difference between any typical machine learning pipeline and a deep learning pipeline is exactly that the feature extraction is actually embedded inside the learning logic itself. Um, Machine learning requires ML requires intervention to correct and learn. Deep learning requires its own form of an pass. That's not correct. So in the sense that deep learning, the technique of deep learning can also be used by supervised and unsupervised, right? For supervised learning, you always need an intervention to correct and learn. In deep learning networks, which solves supervised learning problem, will also have to correct, identify the loss, correct itself, and then learn. If you are talking about the usage of deep learning in reinforcement learning, that's where you have environment and the feedback from the environment is being given. Right? The class of three problems, you have supervised learning problem, unsupervised learning problem, as well as reinforcement learning. For the first two things, error, loss correction, and hence, fixing itself will always be there. Right? Okay. I hope that is clear. Right. Now let's look at that. This is what we have been discussing, right? Artificial intelligence is nothing but the umbrella or technique which actually attempts to mimic the human behavior. Learning machine or machine learning, right, is a subset of AI technique, right? In which primarily used to use statistical based methods, right, to enable machines, right, and basically it actually learns patterns from the data itself, right? Deep learning is actually a subset of machine learning which uses a very specialized mechanism, or mimics this neural network sort of concept, and we will see what a neural network looks like, and that is what a deep learning is about. So essentially this is what it is, right? Someone said rightly, artificial intelligence umbrella, then machine learning, and then under that we have deep learning. And deep learning specifically uses this ideation of neural networks, right? So what is this neural networks? What is this neural networks, or deep learning models that we call them as ANN, called as artificial, and typically they're called as artificial neural networks. And artificial term is by now, I think you have understood what it is. Neural is the neuron that is available in the human brain, right? The biological neural network of a human brain is what is been depicted, and network is because many small neurons collectively collect on its own. They are just one small piece. They are very simple units. They just do very simple tasks on its own, but collectively billions and trillions of neurons collectively is a powerful beast which forms the biological human brain. So that is what a deep learning network at its core basically looks like. Suppose you have this problem of classifying what is a cat, what is a car, what is a doll. It looks like a doll, right? And Typically, if you have to mimic neuron activity, what you will do is you're going to put a lot of these circles. These circles can be called as neurons, and somehow you pass this data. On the left side is your raw data, and suppose this is a supervised learning problem, which means that you know that this data is cat, this data is car, and this data is a doll. Then you can teach this machine via these neurons, and we will see how at the output it knows that, okay, this machine, after once you pass the data, it knows via this neuron that what is what, and it learns from it, right? That's, and it is able to recognize patterns in such a way that it can detect, what is the features of a cat is, what is the feature of a car is, and what is the feature of a doll is, right? So that's the circles, each of them represents neurons, right? In the deepness, this term deep, right? And the deep refers to the large number of neurons, right? On its own, each of these circles are a very small, tiny unit. They don't do much. And we will see that. We will see tomorrow that they actually don't do much. There's a very simple computation unit. But aggregated, if you put a lot of billions and trillions in your mind, right, that becomes human brain. And they do a very complicated function. It is almost similar to, you machine learning folks will remember, in random forests, on its own, one tree has no, meaning. It's very simple. It's on its own is nothing. But a forest is powerful, right? A forest is generally powerful than a tree. On a similar concept, but if you have to relate something, an analogy with D trees, but on a similar concept, each neuron on its own is very simple, and they connect, all of them connect with each other in some mechanism. They, with some links. Information generally flows from left to right to know something. Information also goes back from right to left, and we will talk about that tomorrow. And that is where the learning happens, right? The deep, why it is deep? The deepness comes from number of layers, right? Each of this layer, if you actually see this, let me just change this to this pointer. Then each of this layer is nothing but, represents many neurons, and the number of layers that we have represents its deepness. Okay, a very simple neural network might look like this. It will always have a starting, which is nothing but, in this case, the first layer is always called as is an input layer. It's not exactly a layer in a neural network, but it's the inputs, the raw input, the features that you are trying to put the network to. And then you will have a hidden layer. It can be 1 to n. A simple network can be something between 1 to 10. Okay, nowadays anything between less than 10, 20 is a simple network, right? Earlier, one of the first neural network, production ready neural network, was done by Yann LeCun, if I'm not wrong. And he's a very famous scientist. He's the chief AI of Facebook, by the way, if you don't know, if you know him, right? What is this? Just 1 second, guys. Okay. So he's the chief AI of Facebook, right? And he used a 5-layer network to detect handwritten digit recognition, and it was in production in some bank. Okay, and nowadays if you see, the networks goes to thousands of layers. Okay, extremely large number of thousands of layers. Does DL, which includes statistics and predictive modeling? Okay, understood. Okay, is there the deep learning which includes statistics and predictive modeling? Okay, we will unravel these individual pieces and what it means, and we'll see how it lands it. But the deepness, okay, nowadays just understand that the deepness comes from the fact that how many layers you have. Nowadays the layers have extremely large number of, that number of layers can go to thousands. Okay, and neurons can be like really in billions. I'm talking about artificial neural networks, right? And the models that come out with, right, it's really large models. On an average, there is a large models coming out every 2 weeks or so. Google, OpenAI, Facebook, all of them will actually, Microsoft, all of them will compete and give this model, that model. There's a language model called as Lambda, which was released very recently, or a DALL-E, if you know all these things, and you should know. And these are very, very extremely large model. The model itself is like hundreds of GBs. Like literally, it's so big that you can't even fit into one RAM. It needs like millions and millions of dollars to just to train. Okay, um, uh, and so those kind of deep networks are already available nowadays, right? You might ask that, okay, understood, but we had this traditional machine learning model and we had the statistical learning part. We had SVMs. What happened suddenly? Why, you know, why do we need these large neural networks? There's a couple of things that has happened, right, fundamentally. One is that the compute has started to increase, right? Your compute needs have increased and you are getting really good systems and the data has exploded, right? So as the data increases, if you have to put a graph like this, and a very intuitive graph and a very true graph, like if you want to plot all the general traditional machine learning algorithms in a scale against the data size, the larger the data size, at some point you will see that at some point this they plateaus, right? Let me just point it. So at some point, the traditional material machine learning models plateaus with the larger the sizes, right? And at this stage, a small neural network with a small set of layers, starts to perform much better than this kind of models. And then you will see at this point, a medium neural network starts to outperform the smaller one, right? And the definition of small and medium is left to human intuition. You can say that anything less than 10 is small or anything less than 20 is medium, and then now anything above 100 is like really, really, and like we don't even see 100 layers. 100 layers is very common nowadays. Okay, it's nothing, right? So but the thing is that what is important for you to understand is that as the data increases, as the size of the data increases, as the volume of the data increases, right? We need algorithms which are high in compute and which can comprehend the data and understand the meaning out of it, right? Traditional machine learning models shallowly could not even come to the fact that if as the data size increases, it sort of plateaus somewhere here, right? And large neural networks with lots and lots of neurons can actually, bring out lots of other information which a traditional machine learning model was not able to attain. Basically, this is one of the important thing that you should understand, that why neural networks generally have been fairly successful, right? Let's look at some of the success stories from the last decade. If you actually look at the search trends, it's always hot. The pivotal point is when in 2012, right, this large ImageNet data set that was created by a Stanford professor called as Fei Fei Li, right? She is a very, very popular, very, very well-known, expert and researcher from Stanford. She embarked on creating this extremely large, data set because availability of data was less, and she created a really large 14 million level images, right? On that, there was a competition formed, and then every year there was this competition then started, right? Around in 2012, this historic paper and this model, this neural network was trained, called as AlexNet, okay? And it was trained by three guys, and you should understand and know them. One is Alex, another is Ilya, and another is Jeffrey Hinton. Ilya is right now chief data scientist. Ilya Sutskever is the chief data scientist of OpenAI, and Alex Kirsosу is also very famous. Okay, Jeffrey Hinton is godfather of deep learning, right? They say. So what has happened in 2012 is that this particular neural network called as AlexNet, and this paper, actually you should see this paper, it surpassed the last ImageNet challenge. The challenge was to basically, can a machine identify all the images, classify all the images? There was 1,000 images. How good can a machine identify those images? And this neural network outperformed by about 17% or so, right? And people were stunned. People thought that what has happened? It's like how can someone become so good in about a year or so, right? So that basically came, brought back the whole focus back to neural network from 2012 onwards, if I must say. And in fact, there is a let me just share you something. There is These three guys also did something else. Okay, what they did at the same you should read this link. Okay, I'll send you this link. Okay, this is a documentary from Wired, where after AlexNet, what these three guys did is that they realized that they're onto something, and they created a company which were protecting their research, and then they sold this research to the highest bidder. And you know who bought them? It's not very surprising that Google actually bought it for extremely large amount of money, all of them, and all three were actually at some point of time with Google. And then you should see that from 2012 onward, the curve of ImageNet challenge was extremely high, and at some point it went above and beyond human challenge. Like it actually beat a human level threshold, basically saying that the machine has beaten a human level threshold of identify images in the ImageNet challenge. That was actually a one tipping point on, at least on computer vision. Okay. On the same year, Google Brain team also trained a neural network to recognize cats by watching lots of YouTube videos. They saw a massive jump on 70%, right? Couple of years back, this was a very famous use case from Facebook, where they were actually deciding, whether we have a human face or not. Okay, they use eyes. Okay, your eyes are open and you have eyes, and all. It used trained using like a number of million images, four in this case, uploaded by Facebook users, right? And this was fairly successful as well, right? This was also very very popular, and there is a you should see this thing in YouTube. There is a article about this documentary, full documentary from DeepMind, again a Google company. Now it's a Google company. What they did is that they created a reinforcement learning based program called as AlphaGo, which was playing Go. Go is this highly complicated game, right? It has the permutation combination to win or make a move is like, it says that it is more than the atoms in the universe. It's such large. It's like quintessential, like thousands and millions of times more complicated than chess. So that game was trained, AlphaGo was trained, and it actually, it was able to beat a human professional. And then later what they did is that AlphaGo Zero was built, which actually beaten that same program called as AlphaGo, right? So there was this documentary. Lee Sedol was the all-time champion of AlphaGo from South Korea, right? The game actually beat him 4-1, and you should see that documentary. If you haven't seen that, please see that. It's a pretty interesting documentary. It's there in YouTube. Okay, very nice. Okay, and it's from DeepMind, and DeepMind is this highly deep tech startup who only works on this kind of things from Google, isn't it? And in fact, DeepMind went on to build AlphaStar, which was, which is a reinforcement based learning program, which has beaten this some top professional player in StarCraft. If there are any games fan, you would know that strategy games like StarCraft are really, high end games, right? They went on to actually create something called as Fold, right? This year, right? 2022 or 21, which was, trying to unfold the genes, the protein synthesis problem, right? So there's a lot of things happening, and these are all live, real cases, which has, it has a huge impact um, on our life essentially, right? Okay, so I think one thing we have established that AI, neural network, is not going anywhere. It's here to stay. Okay, it has impacted almost all of it, whether we know it or not. Anything which is large data and split second decision has neural network in it. Your Google Maps is a neural network based engine, right? Everything that you do is almost has some part of it in neural networks. Okay. So now next question that prompts is that, can machines automate a human visual system? In 2012, it was known that machines can identify better than humans, but can it actually do much better? One of the use cases that we will discuss now, and we will only discuss use case, we will not um, go to any code or not, but we will see that how this problem of self-driving car is actually been attempted, and we know companies like Tesla, Google Waymo, and others have tried it, and if you are following this industry, Tesla has made some significant improvements, right? So, typically, if you see a self-driving car uses a variety of cameras, right? In anything that if you are driving, we need lots and lots of inputs, right, to drive, all right, isn't it? So, what are the self-driving cars does? So, basically, it needs lots of input. For a human being, the input is nothing but your eyes and your ears, right? You need to know who's honking from behind. You need to judge, right, and so on and so forth, right? Yeah, sensors, right? So for a self-driving car, so we have a, I don't know whether we have sensors or not. So that's one thing that I want to discuss today here, and maybe I want to put, and that is where Tesla is actually has an edge. But the self-driving car essentially uses a lot of inputs like cameras, sensors, lidar detectors, GPS location, and tries to make some decisions, right, about how to drive. Now, the question that you can ask, that why is there so much excitement, right? Why do we have to solve this self-driving? What is this thing? Uh, you know, Autonomous vehicles has a lot of applications, right? Planes are autonomous, right? You know that, right? I mean, many other planes are autonomous. There is no problem, you know. So the natural thing is that why can't we make cars autonomous, right? And then it has lots of facilities, right? UAVs. And the more important thing is that you can actually carry goods, right? Self-driving trucks, right? Can become a reality, and driver and maintenance costs will reduce, in the sense, essentially, again going back to that question of labor, right? The more you democratize AI everywhere, you have low dependence of human beings, hence you have extremely or to no cost of labor, right? So that will actually help us to reduce and make significant improvements, right? um, I won't be able to. Let's not go over this. However, it's very clear, right? There is significant some advantages of self-driving. You can, if machines don't make mistakes, and we know that humans, 90% of our accidents are caused by human error. So think that amount of life that we are going to be saving, right? Apart from the fact that every time you brake, some people will press the clutch, and if you are not in a automatic car, you might not be efficiently driving your car, and hence your energy efficiency is going down, right? Those kind of things you can just alleviate from an automatic system altogether, isn't it? So there's clearly multiple different types of advantages for automating this particular problem statement of driving itself, right? Um, while it's also good, historically, the Society of Automotive Engineers has defined that what do you mean by an autonomous driving? And what they have done is that they've actually formulated five parts of it. If I'm not wrong, there are actually five levels of driving automation, and we are at three, right? If I'm not wrong, we are at the conditioning automation, right? And full automation is still a dream. Automation is definitely working. If you are following again Tesla, and they have just recently launched, right, 12,000, with the $12,000 extra, you can get that FSD beta, full self-driving software in your Tesla, and it will help you. Though the laws don't support it, right, it still require you to put your hand on the wheels. Okay, that is important for you to understand. But these are the level of certification program, you can say. Who are doing these things? Tesla, Nissan, Google Waymo. One of the things that Tesla is doing, which from the very beginning was a distinct difference than everyone else, was this extreme focus on only vision. Tesla had other sensors, but they they were hell-bent on not putting LiDAR, right? And even any other trackers, okay? They said that if they can solve vision, and because human beings, you and me don't have a sonar system, right? And so this Waymo had a sonar system to detect distances and so on and so forth. We totally and 100% rely on our vision cortex. Whatever we are seeing, from that itself we can comprehend the depth, how far it is, and everything. So Tesla's motto, which was unique, and that is they have made a significant progress on that, is that we can solve this beast using only vision, and they have built infrastructure over the years to only focus on computer vision. In fact, they have never taken LiDAR, if I'm not wrong. They are in fact planning to remove the radar also. Okay, because the radar was used to actually do a feedback loop. If you want to know more, Tesla has this AI day, and last year they presented a very detailed things that they did and they had accomplished, and it is pretty remarkable what they did. Okay, just using computer vision. And they actually don't want to use any sensors. They only want to use sensors just to reconfirm the vision system, which is pretty cool on its own. Okay. Yeah, Dubai. Yeah, I think there was a lot of things, right? In US, Dubai, there's definitely yes. The made to be level 4. In US also, in some areas, there's thinking of doing it, right? And democratization is like it's going to go to the next level altogether. Though it still remains to be seen how it will be in a congested area like in probably in India or other places, right? But I have seen self-driving cars here getting tested, at least the place where I'm from. Okay. Um, in timeline with what you said, is that we're looking at phase to phase 4 around 24 25, but again phase 3 is definitely achieved. Okay, it's come at least to some extent, right? Phase 4 is what we're looking at in a couple of years, and it's at that time I think it's going to be um, extremely awesome to see what this can do, right? And then think about it, just a end-to-end AI system which is doing driving, seeing everything, assuming everything, and just driving as it can. Like it's not just cruise control on your button, right? It's not that you can, so it can detect a lot of things and take decisions as we go, right? Okay. So how does a self-driving car work or see? What does it do? What are its input? It generally uses sensors. Someone said lots of sensors, and cameras. If you actually take this specific company called as Tesla, right? It has eight sensors because it's more publicized. That's why I'm saying Tesla. It's not that others have other things as well, but it has eight cameras. Essentially, it wants to see everything that is happening. Okay, and it's an onboard computer which actually processes live video feeds. This camera are nothing but video feeds, and they basically actually do live video feeds, and there's a neural network system, right? The model inference engine is there, right? Which tells it what to do, and then there's a decision system and so on and so forth. There are other systems like radar sensors or lidar systems which can complement the vision system, right? If it but this is what you need to make a self-driving car equipped with an equivalent of a vision, right? It just tells us that put a human being, it doesn't need all those things, right? It's how complicated it is to replicate a human being driving a car, right? The factors are enormous. If you actually look at this picture of a busy intersection where a car is going, right? For us, it is just so seamless. We can identify each of the objects, right? We know exactly what is happening on the surrounding. We have a very clear reasoning approach. We know that this is a busy intersection. We should pause. In fact, cars are stopped. If there is a traffic signal, traffic light ahead, we should watch for it. There's just so many things that is happening, right? And it's easy for humans to actually comprehend, right? It's mighty difficult for the machines to achieve that. But if they have to do it, this is what happens is what you are seeing in this picture is nothing but object classification, where we can say that this is a car, that's a bus, this is a car, that's a traffic light, there's a person, there's a handbag, and all the things that are getting marked, okay, and all the things, there's a building. So I need to know all the things, right? Once I know all the things, so the class of problems of knowing the things in the computer vision is called as object detection, and I need to be highly precise about it, right? I cannot simply say this person, okay, is somewhere else, right? I cannot say that, right? It will be bad. If this person is here, so then I'll make a error, a judgment call, bad judgment call about it, isn't it? So it has to be with high precision. However, along with finding where is this person, I also need to know one more thing, is that where is this person in the vicinity of this picture, right? I need to know if an image can be divided into a coordinated system. I need to be aware of that this particular image, this particular car is located in the center of the thing, not on the left, not in the right, but in the center. There are windmills which I have to you know identify, but I also need to know that it is actually far, right? This concept of far, or it is in this coordinate of the image, and then I can make some conclusion about it. The problem of you know finding the location of an object in the picture is called localization problem, right? And localization is um, just let me see the chat window if there is any question. So localization is a regression problem, and we can. So this is a very important for object detection plus localization. So this is a question, sir. Can I take this course before machine learning, even though I have good knowledge of from college? Yeah, I think you should be able to. But you would need some machine learning concepts. Actually, it's better to actually do machine learning and then come, okay, and do that, right? Okay, let's come back to this our topic. Okay. Um, so now the question that we are trying to find out is that in the image we not only have to identify what is there, where it is there, right? If you go back to our supervised learning concepts or machine learning concepts, what kind of what kind of problem do you think it is? Is this class? What is the problem of object detection? Is this classification problem or a regression problem? Okay. Question: is it a classification problem or a regression problem? Can anyone tell? Is object detection a classification problem or a regression problem? It's a classification problem. What is object localization? A classification problem or a regression problem? Very nice. So this is actually a regression problem. So you can see, right, why it is a regression, because you're trying to find out numbers, you're trying to find out the coordinates, right? So now to identify and now to use this idea of object local, we don't say when we drive the car we know exactly the where the person is. We don't just know the person, that we don't just know that there's a human being which is crossing the line. We know exactly the person and where he is in the he or she is in the context of the image that we are viewing, right? So it's actually both a classification problem and a regression problem. And how do we solve this? We use, for a regression problem, one of the ways we solve it is using this concept called as bounding box. We try to draw a rectangle around it. There are other mechanism also, but in this case we try to draw a rectangle around it, and we say that this is my coordinates x and y and my length and width, which will give me the whole of the coordinates, right? That's what we do, and we will see that CNN is covered. Yes, CNN I think is covered. I think we will go through this. I'm not sure, but I think we will go through this. If not, we can actually take a small session around that also. Okay, right? What are the challenges that a self-driving use case represents? And this, why are we discussing so much? Because you can imagine a practical scenario like self-driving car. The problem that it surfaces is not a problem for this use case. It's a problem for a generic AI itself. If you have to build a generic generically vision system, right? One has to be aware of these problems and has to solve it. Though you are trying to solve it for one use case at a time, you are solving for the greater good. If you are trying to, build a human level vision system, isn't it? So various problems. Your cameras might be faulty. You might have a occultation problem. What is illumination? Let's look at it. Light shading can actually change. Okay, if it's dark or if it's a very bright condition or a dark condition, right? Things change. Rain, fog, visual issues, which are nothing but inputs. It might lead to false objects, right? False objects been detected. Not only false objects, also where they are detected, right? Moving objects, okay, images, videos, we see in a video frame, right? Everything is video for us, it's live, right? So 3D objects change their shape and appearance when they are in motion, right? This is the picture of a same person, right? How do you teach machine that they're both same, right? That's important, right? Detective images with abrupt motion changes, right? These two are same context, same image, might be easy for you, might not be easy for machine, right? And how to track this across, right? Occultation is a very real problem for you and me. It is very easy. It's the you know this human being and his dog, his or her dog is walking, and then they go behind the tree and then they come out. If you take them independently, the machine will make total mistake. They have no idea. Okay, one time that the object was there, second time it was not there, right? So this is a occultation is a very important problem for them to solve, and this is a real life problem. We don't have a problem. Systems will have to somehow model this and solve it, right? Camera, right? If it is bad, your hardware is issue, right? How do you do it? If it's fuzzy, right? Your input system is gone broke. How do you handle that, right? So these are core fundamental problems that one needs to solve to actually build a super class vision system which is comparable to human being. And one of the reasons that people are doing is by solving this use case of self-learning car, self-driving car, not self-learning, as in self-driving car. That's one of the reasons why this is hot, is because there's a combination of hardware, software, and AI research going on to solve this, which people say will solve the vision, and at least we will be able to achieve human level vision, right? Okay, so now the thing is that how do we do it? What is this? How do we do it? We extensively use a specialized method called as CNN. CNN is a convolution neural network. We will look at, yeah, I told you, right? We will look at chapter 5, and we will see that how do you actually do and do all those things using something called a CNN, which requires a greater computational resources to do. Okay. Um, let's look at some of the other applications of deep learning. We have seen that gaming, right? Self-driving we have discussed in detail. Healthcare, right? Machine translation, end-to-end neural network, nothing else. I mean, it's almost impossible to have anything apart from neural network. 2017, when Google changed this translate engine to a totally neural network based machine translation, it was one of the largest model at that time. Nowadays it's like dwarf, but it's actually at 2017 it was really blood. Computer vision, social networking filtering, facial recognition, augmented reality, AR, VR, Meta or the Facebook is doing a lot of work, right? And Facebook is one of the pioneering effort on everything to do with vision. They do a lot of work, right? Gesture recognition, right? And if you actually know this, right? Google has this Google Lens, right? You type something and it shows the dog, or the picture of whatever you said, right? This is text to image or image to text, right? In fact, you search something, it will search a similar images across, right? You can improve images, right? You can color code them, you can color and you the filters, right? All of us use those filters, right? And you will see that though all of it is not neural network, there's some convolutional operation, and we'll look at that. What is this operation that makes it unique, and how we can add it in this thing. There's also cases where we do deep fakes, if you know what it means, right? This is, yeah, all of this is computer vision. Full of computer vision is all of neural network, everything. Machine translation, all of neural network. Okay? Everything that you would use, Alexa, Siri, everything is neural network. Translation is 100% all of deep neural network. And language models are like one of the largest models that you see, right? You know, huge models, huge. Language, they say, is actually a picture speaks thousands of words, right? So you need more inputs. Data density is much higher than language. Yes, NLP. Though we will not touch upon NLP in this course, but that's also a heavy duty input to model intelligence. You need to understand language to understand intelligence, at least at a human level intelligence, isn't it? Because there is so many ways one can express what is happening in my environment is via language, right? And we can see that Gmail autocomplete, it has become a standard feature now in Gmail, right? And it works so well, right? It's astonishingly well. Translate, auto translate. You can take a picture. You have seen this, right? You can take a picture, and you can just choose what it is. So, image to text to translation, all at the same go, right? Yeah, it feels also very formal. That's correct. Healthcare, lots and lots of applications, right? Though in healthcare, we also have to worry about the fact that it is very much highly interpretable, right? One has to also explain what has happened. You cannot go wrong here, not even with one case, right? Especially with drug discovery and image analytics, right? COVID-19, right? You know this, you understand, right? That the vaccine, earlier the vaccines used to take so many years. This time they did it in 1 year. 1.5 year, whole world is almost vaccinated, right? Not a matter of joke. And machine learning and deep learning has accelerated it big time, helped it big time. Um, um, Social networks extensively used deep learning, right, to find out what is happening, okay, and a lot of other information, because they fundamentally, the fact of the matter is that wherever there is large data, you can see this one trend that is coming out, right? Large data healthcare, machine learning, extremely large data, right? Computer vision, large data, right? Each of the images is of large sizes, right? Each of the image that you take in your phone is averagely 2 to 3 MB. That itself is huge, right? And if you actually put it in one dimension, and we'll go through it how we do it, that's a lot of features, right? So wherever we have large data, clearly deep learning is the de facto need of the R, and any other traditional machine learning algorithm, if you remember that graph, will fail. And believe it or not, we are surrounded with extremely large data and the problem that we have to solve, right? Dynamic graphic rendering, you can see this, the first image, this is called as object segmentation, right? This is a better way to identify. Earlier we used to draw boundaries, now we can actually literally segment. Like when you draw boundaries, you actually miss some parts, right? You overdraw or over classify a object, because an object is never a rectangle shape. None of us are rectangle in matter, right? So here in this case, you literally draw exactly how it is, right? And this is how nowadays the self-driving cars actually see, not the bounding boxes. Okay, that's what they do. They can recreate the whole environment on its own. Neural network playing FIFA, right? Um, it's going to a lot of things, right? Okay, a little time check. Okay, we have half an hour left, and just let me see if we have any obvious question that is coming in. Why do we have to go through this? Why do we have to understand all those things? Because understanding helps us to. If you don't understand what you're dealing with, it's difficult to learn. Generally, right? Um, it's been used everywhere. It can solve a lot of things. Hence, it is good. Obviously, the obvious choice is to basically learn it well, and that's how you are here, right? Human beings can learn with very few samples, right? That you don't need an extremely large number of samples. Even if you suppose you are teaching yourself deep learning now, you don't need to watch this video or attend this lecture 50,000 times. One, two, three, I think you will get the gist of it, and you will probably be an expert by then, right? Machines are not like that, okay? And one of the major areas of focus is that how can we do this one shot learning, right? How can we teach machines to be really one shot, right? And there's a lot of work that is going on. It is also not possible to label everything in the world, right? It's while data has become abundant, you can't label everything in the world, right? It's virtually not possible, right? Understanding concept, deep learning does not understand context very well. It lacks perception, right? Some say that it's a good in a copying technique. When you see the image on the left, and you can see what's happening in people's mind by a look at their face, right? While it is virtually impossible for a machine to understand what's happening, right? Image classification is not equal to scene understanding. That's a very important thing. That's the next level of reasoning, right? And deep learning is still not there yet. It's very much a black box problem. Okay. What do you mean by this black box? It's a thing that where you have an input and output, you don't know how it is happening. Okay. There is a lot of work happening in XAI called as explainable AI. Okay, where people are trying to build tools and frameworks to explain how a neural network is working, because they have built this thing, researchers, but they cannot really explain it, that how it has actually 100% arrived at a solution. If you take SVM or if you take linear regression, you can say that this is the reason why it is this, and this is the reason why it is not this. In case of neural network, it works perfectly well most of the time. People don't know how to explain that. And in cases, suppose, which is important for you to explain, it falls short, right? And that is one of the problems in finance and medicine. If you know what that means, right? There is you need to be very good at explaining things, right? The networks that has arrived now are really large models. Okay, and the need for large is never less. This is 5 years outdated. I can tell you guys, this is nowhere near practicality. What has happened in 5 years is simply astounding. If you see that in 2015, Microsoft released something called as ResNet, a residual neural network, focusing on image problems. Okay, and that has around 60 million parameters. What do you mean by parameters? Can anyone tell what is parameters here mean? Any machine learning folk who's around and can actually tell what do you mean by parameters? Questions? No, parameters is not equal to variables and dimension. No, it's not independent variable. Independent variable and variables and dimension, no, it's not. Capacity of what? No, it's not the features. Features is what is the features or labels of the input. Parameters in this case tells you that the learning parameters, these are the weights and biases, these are the coefficients. Perfect. If you actually specify this term coefficients, no, not the capacity of storage, but coefficients, if you have to generalize it, a learning model actually stores numbers, which are nothing but weights and biases. Okay, it's not the pixels, no. A machine learning model, we will discuss this. In 2015, the ResNet model had about 60 million weights and biases, coefficients. Okay, and that is what a learning parameters of a machine learning model is. Okay, it uses exaflops, right? 2016, Baidu 300 million parameters. 17, this was this Google translation engine, right? 8,700 million parameters. Really large vector, right? Huge vector size. Nowadays, that Megatron, right? What is that thing that get 500 trillion, 100 trillion parameters, which means like it's an extremely gigantic model which has extremely large knowledge, and it's a language model, by the way. Okay, it's achieving. GPT-3 was about 175 billion parameters. Megatron was 500 billion parameters. You can think of it, right? Which is like extremely large, and this requires huge machines, like these are exaflops, petaflops, these are like supercomputer style machines, right? Requires to train. If you actually watch, people have gone beyond CPU and GPU. You know GPU, right? GPU is not graphic processing unit. Every machine in the world has what it powers your monitor, right? All of them have, right? It's what powers your monitor. In cases of, they found out a way that when we can add a GPU but don't put a monitor and use the GPU to train, right? So that your you can just, it's free thing, you can just use it, right? People have gone beyond and built their own ASICs. ASICs means like focused processing units focusing on only AI workloads. And fundamentally, AI workloads are nothing but floating point operation or matrix multiplication. At its lowest level, at the bare metal level, it's nothing but a matrix multiplication or floating point operation, right? So they are focused and tensor operation essentially. So they have built chips which only focus on that, right? There's different names. TPU is a name that is given by, I think, Google, right? Or then Tesla has built a unit. I don't know what they're calling that. That is also focused on machine learning workloads. But these are things that are getting built. It's not only the software and algorithms. There's a lot of work that is going on in infrastructure as well as in um, the the creating the new hardwares, which is like the fundamental side. You need the hardware also is scaling like anything, right? Okay, I think now that we have said enough of what it is, let's look at one specific um, type of algorithm. We will not explain this much, but what he's been trying to tell you is the like CNN, which we will discuss in chapter 5, is what has been said, right? We also have one more type of network which is very popular in time series kind of a scenario. And if you have done time series modeling in classical machine learning, right, even in statistics also, you know that this is a problem that has been there for a long time, right? How to predict stock market prices, okay? Weather predictions, time series, right? You have time is a feature. You have to model based on the time, right? So LSTMs are a type of neural network. They are also called as recurrent neural network, whose parent is nothing but recurrent, a type of neural network which does this kind of predictions very well. And they are used heavily in language, because language essentially is a time data, right? The sequential data, images, and so on and so forth. And basically, we will not discuss how it does it, but it has something to do with how we process our language, and how do we keep a small memory, how do we maintain it across, and how do we handle the context. LSTM's full form is long short-term memory. Long short-term memory. Its objective is to understand the context and then predict the future. That's all it is. But at its lowest level, it is a build-up of 8 neural networks. Okay, one unit of LSTM is nothing but, if I'm not wrong, 8. 1, 2, 3, 4, 5, 6. Yeah, 8 bits, eight pieces of network, which makes it one LSTM unit to understand. And the importance of its language is imperial, where it gives you the understanding of context using this kind of network. Okay, this is what a typical LSTM cell looks like. We will not go to the detail, but all of this essentially uses these joins are nothing but in neural network on its own, right? Um, Fairly large uses of sentiment analysis. You can have a bot. It says that how good, bad, and ugly. I know that good means really, the good means that you are trying to give a rating of 5. Bad means you're trying to get a rating of 0, something like that, right? You're trying to detect what is my sentiment, right? And we will not go through this. I think we will have time to go through this. Yeah, so essentially what we just this explains that how we can solve these things, right? And we will actually come back to this. There is a specific, if I'm not wrong, RNN. Yes, RNN is on 7th day, and we will actually look at that, right? On its detail, right? Um, Awesome. That brings us to a place where we wanted to discuss that, like any other deep learning any other project, right? If you want to build a project, you want to build a house, what will you do? You will do planning, right? You have to gather information. Where will you do? How will you do? Who can do so and so forth, right? That's what will you do, and then you will actually start building it, right? And then you will have to do evaluation. Model building is one thing, then you have to evaluate, and then you have to deploy and monitor. So any life cycle for of any project has a mechanism, has a process, and deep learning projects are also exactly like that. There is not much of a difference between this and machine learning. If you guys have heard of this framework called as CRISP-DM, CRISP-DM is like those project management like Agile or SAFe, right? So CRISP-DM is a data science life cycle framework, focuses on some parts is focusing on data science projects. And we can use this. Lot of large projects can be handled, can be modeled, can be executed using CRISP-DM. But it's always, few things has to be very clear. Always start small, have it planned, because this is a complex system. Most of the time, 99% of the time, your objective is to, you can build a model. And as you know, if you have already gone through machine learning courses, how many lines of code that you have to write to actually do build a model? Can anyone tell? How many lines of code? First, you have to do model dot. You have built 3 lines, literally, right? Test, train, and split. One line. Do fit. That's it. You're done, and then dot predict. And maybe you have to evaluate. So lines of code is 3 or 4, but the amount. So the core learning algorithm is just 3 or 4, right? But the amount of focus that you have to do it in your feature engineering. That are your features good or not? And the evaluation is what it make it break or make or break, right? Is will tell you that is what will tell you whether your product is or your learning model is ready to go to production or not, isn't it? Good thing is about deep learning is that, remember, many of the feature engineering, hardcore, you know, high level feature engineering is done by the algorithm itself, right? You can, give the obvious, you can help the model better to add some domain specific features, but most of the feature engineering is done by this the algo itself, so that that neural net itself, the neurons itself does its feature engineer. And that's one way to actually reduce that work. But the other way is that it also decreases your ability to interpretability. Hence, why something worked is something that you have to establish to set on, right? The question generally that you have to ask before you start any problems, and it is not something unique in this particular domain, is that if before you start, you find out that what is your problem difficulty. Is there anything that is already published? Because this is a very, very highly active researched area. Okay, lot and lots of work is going on a daily level. If you have, if you are in the right blogs, if you are reading the right set of things, like for that matter, I told you AlexNet, right? Ilya Sutskever, right? If you follow this guy called as Lex Fridman, he does tech talks, right? And he gets big guys like Elon Musk, Mark Zuckerberg, and all the AI folks. He will get it, right. And he's got recently Jan LeCun and Ilya Sutskever as well. You should watch that. Okay, it's amazing the way they people, the conversation that goes on. So if you are watching those things, you should know that this is a very active area of change, and on a daily basis there are new things that are coming up. So whenever you've been, um, I will drop the name. Okay, you just look at AlexNet and the second author. Okay, and Ilya Sutskever. Okay, but the question what I'm trying to say is that if you have been given a problem and you've been asked to solve using deep learning, look at if there is already some work has been done or not. Number two is that how costly. You need to understand your cost matrix, right? How frequent are the no, what is the cost of your mistake, right? What is the cost of your not being interpretable, right? Okay. And how frequent that the system needs to be right. These are very important, right? How hard it is. The third one is difficult, is important as well. Is that how hard is to acquire data, right? How is it? How it is expensive? Tesla had a 1,000-member team who was doing leveling, right? In fact, they recently did something else, but they had a 1,000-member team who was doing leveling, the image leveling, right? And making the models more and more important, right? And how much does it need, right? So the way Tesla did it is like there is a million cars in the fleet. All the cars are showing, returning all the cameras and all the pictures to the Tesla headquarters, and the training is happening on that. You can imagine, right? It's collective mind. All the cars are actually working unison to make that whole model much better, right? So you have to build this kind of infrastructure if you don't have them already, right? Um, right. So that's, and of course nowadays we have lots of cloud companies, private leveling companies, which can help us various aspects of any data science or a deep learning project. We have to use them. We have to. There are different ways of handling things, but that's what we do. With anything else, any other machine learning problems, one of the things that you cannot escape is hyperparameter tuning. If you have done machine learning course, you know that how important is to hyperparameter tuning. By the way, what did we use for hyperparameter tuning in a typical ML scenario? Does anyone remember? What step we used to use? No, that is alpha is one hyperparameter. I wanted to understand that how do you tune hyperparameter in a classical machine learning problem? You do cross validation, right? You can use cross validation using different types of hyperparameter and find out the best model, right? You have to use similar technique here as well to find out what is the alpha is just one of the hyperparameter. My question was, how do you know what is the best alpha, right? So that is the tuning of the things, right? Right. And the last but not the least is typically your deployment and monitoring. You have done everything else, awesome. Now it has to go to production at some point, right? And you put it into your web server, and then it's been exposed via some API. Mostly, what is exposed? Your inference API is generally exposed, isn't it? The prediction API is essentially exposed, isn't it? Can't we use linear regression? Let's talk about that. I think this is the end of it. Okay, we have come to the end of it, right? So let's do one thing. Let me just take you to a specific. Let's draw this thing. Okay, let us clear this and let us. So now let's assume that you can all see my screen, right? You can all see my screen, right? Quickly. So let's assume that this is my data points, and I am just saying that, okay, and this, and then maybe here I have 3. So now let's assume that this is my data point. Okay, clear? Does anyone have any confusion with this question, this particular graph that I have put it? What I have done is that I have two features, x1 and x2, okay, and I have tried to just two colors. Yeah, these are all data points, right? And if I have to put a classification engine saying that which data, which is red and which is blue, what will I do? I will use linear regression, and I will say that build a model using linear regression. What does the linear regression do? It tries to draw a best fit line, right? Okay, so you have this best fit line. Then you have that for a best fit line. What do we have? We have that. What do we have? We have your m man x, right? If it's this is a two-dimensional architecture, so we have your coefficient, right? So now suppose I have another image, right, of some, I don't know what is this. Okay, I need to find out. This is in my new data. So if I actually apply this line equation on this, I will find out whether it is red or blue. Clear? I have no problem in this, right? What type of data is this? This is a linear data. Suppose I have the same, right? Isn't it? So now suppose I have the same data set, and the data set looks like this, okay? I'm just making it more complicated, guys, nothing else. Huh? Now tell me, sorry, can you draw a line to find out exactly? Is it easy to draw a line? Actually, let me make it more complicated. Huh? Why not? So now, okay, and I will do blue. Suppose these are two data sets. Can you, why can't you draw a line? Oh, you can draw a line. Of course you can draw a line, right? So I can draw a line. I found out a best fit line. Does this line represents, no. I'm not talking about solution. Does this line represents the best cut, the best decision boundary to segregate my red points and my blue points? It is not. It is not representational. Why it is the case? Can anyone tell me why? Because the data points are not linear. Linear regression at its own uses, assumes that your data is linear. Unfortunately, all are mixed because they are not linear, because the dependency between these 2 points are not in a linear relationship, right? Linear relationships, what do you mean by linear relationship? That means this is very simple, right? There is some sort of linearity. You grow, I grow, you go down, I go up. Some sort of relationship is there. In this case, the relationship is not linear at all, right? Everywhere, every machine learning algorithm, wherever you have data like this, it will fail miserably because your linear relationships does not work, right? So this will definitely not work. One machine learning algorithm will work, called as SVM. Do you guys remember what SVM is to do? What will SVM do? It will actually project this. It will add one more dimension, okay, Z, and it will add maybe two more dimensions, and it will try to project this data points into different features, and then at a higher dimension it will draw a linear boundary. It is still a linear model, by the way, right? But more and more, when you think, right, how much, wherever you have data, most of the data around us is non-linear. It is not very linear actually, right? So at a very large scale, your linearity goes away, and hence all these models of this classical, one of the reasons is this classical machine learning model, which are fundamentally at its core, many of them are linearity, right? Many of them are actually linear model fail. Neural network is fundamentally non-linear model. And no, I'm not talking about unsupervised, supervised. I'm just talking fundamentals of why a linear model fails. What is this idea of linearity, right? And what it defeats, why it cannot represent two data who has some relationship, which is a linear relationship. We will see tomorrow that to represent this non-linearity, two things, right? We have linearity, right, and non-linearity. Everything around us is non-linear. Most of the world is non-linear, right? Not always that whenever there is no relationship between, there is some relationship, but it is not linear, and you cannot use a linear algorithm to on a non-linear data set, right? That is difficult, and you need to actually address a non-linear equation, and we will see that this problem statement of how do we do that is, we will see in neural network, right? Why this non-linear and how does it achieve it, okay? And that is what we will actually see. Of course, apart from that, the fact that at some point, this algorithms were also not very SVM was very compute heavy, right, for one specific reason, and neural network is much faster and much this thing. So, yeah, I think we are done. We are almost done. We have reached to the end of our point. What needs to happen is now that tomorrow before we start, I will ask, let me just do one thing. Let me stop my sharing, okay? And I will ask um, to share the data set for tomorrow's. Let me do that first. So there is a data set that needed for tomorrow that needs to be uploaded to your um, Python notebook environment. Okay. So this link, what I'll do is like I will share with our learner success manager Asha, and Asha will share to you all of you. Okay. This is a MNIST CSV dataset. You should download it and put it in your Python lab. Okay, for tomorrow's code, and then we will see what we can do, right? Okay, and yeah, I think that's that. I think that's we have come to the end of our first session. Tomorrow is going to be a little hands-on. We'll go deep into the we will go deep into the artificial neural network, and we will actually run through. We will do a bare bone neural network. We will build it without using any framework, and we will try to babysit it, and we will try to understand what is its core problem, and we will see that how to build it. For that, our learner success manager will share the link. I have just sent her an email. She will share the link. Please download that CSV file and upload your code as well. And all the code is already there. You have to upload the code as well. Let me just check once whether the code is already available or not. I think the code is already available. Yeah. Yeah, I think the code is already available. Yeah. So what is the expectation is that though it is assisted, we will both code together. You will also code together, and we will also code with us. Then it becomes easier. Okay. There is one more point that I wanted to talk is about how to raise issues in the community drive. Sorry, the community portal. Okay. Asha, do you want to send me that link so that I can send the learners right now itself without spending much time on it?
Sir, do you want?
You said that, right? That we have to tell that how to raise the, yeah. Can you give me the link? Yeah.
No. Yeah, I'll post the link chat box, but I told you, teach the learners how to raise a ticket in LMS.
Okay, so maybe we can do it next week.
Why? Because some learners don't know.
Okay.
Yeah.
So maybe I can do it tomorrow.
Can you please take it up, or else I can't take it?
Yeah, you can take it also, no problem. You want to take it? Yeah. You are there, Asha? I think she went offline. Okay, guys, I think yeah, I think this is what it is. Yeah. Okay, you can see that, right? Okay, guys, is there anything else that we have to do, or let's call it a night? We are 4 minutes ahead of the schedule. Let's come back tomorrow at same time. Thanks a lot. Have a great night. If you are in this part of the world, have a great day ahead if you are in somewhere else. Okay, see you tomorrow. Thank you very much. Thanks a lot.
Am I audible now?
Yeah, Asha, you are audible now. Asha, what we can do is like we can do it tomorrow. You show me how to do it. I will I will, at the start of the session itself, I will show them, okay?
Okay, okay.
Yeah, I'll do that.
But now I will take 2 to 3 minutes of time. You can leave the session.
Okay, no, I'll also be there. I also want to see that, right? If someone asks, I also say. I'll make you the presenter. Shall I make you the presenter?
Yes, yes. No, no need, sir. I'll take it up. We have given. And but please don't share any WhatsApp links in the chat box. Please don't share. Ma'am, are you there? Can you please share your screen so that I'll explain you how to raise a ticket? I will give you the presenter rights.
Yeah, please do that.
Can you please share your screen?
Yeah, sure. Please give me the presenter right. Can you give me the presenter right, Asha?
Yeah, sure, sir.
Yeah. I'm in LMS.
Just go to your LMS.
Yeah, I'm in LMS. Tell me.
Just go to the first page, sir. So just 2 minutes.
Yeah.
Go back.
I think it's logged out for whatever reason. Just 1 second.
Yes.
It's done almost. We are done. Just wanted to show you. Yeah. So here, then community, help.
Yes. Just click on help option.
Yeah.
Kaman, I think you are watching this. See, if you have any queries on course certificate recordings, just click on any one of the options. Just click on course. Click on Ask Arya. Ask Arya. Login. Okay, can you please raise a ticket, Kanan? So that's what I'm telling. See, if you have any issues in login, please raise a ticket so we will take it up.
Yeah.
And this is the way you can raise a ticket using help option.
So this is a chatbot, folks. Please raise a ticket. If there is something else, you can just type it and the ticket will be raised.
If the issue is not listed, you can select any of the option, but in description, you can mention your issue.
Yeah.
No, Mohammed, the Q-Drive link is not working. We have some issues. So we are not sharing it, but I will share the notes to your registered mail IDs. The trainer will share with me so that I am going to share with you. Yes, okay, sir. You can stop sharing and you can leave the session now. And thank you so much.
Thank you, guys. Thanks a lot. See you tomorrow.
Yes, everyone can leave the session now. We'll meet tomorrow at 8 p.m. So bye everyone.